In FEA, your first choice of element can literally make or break your entire simulation. So, which building block are you going to choose? This directly impacts your accuracy and your speed.
All right, first up in our toolkit is the 3D solid element. Think of it like a solid block of clay. What it does is fill up the entire volume of your part, capturing the complete 3D stress state. You're basically building with tiny Legos. You get amazing detail, but yeah, it's computationally expensive. They're absolutely perfect for thick, bulky parts like this gear. Here you can see the full 3D mesh. Now, a super common mistake, you can't just apply a moment to these. They don't have rotational freedom. But what if your part is really thin? Well, that's where our next tool comes in, the shell element. So instead of modeling the whole thing, you just model a 2D surface and tell it how thick it is. Just imagine a cardboard cutout or an eggshell. All the important physics happens right on the surface. Look how perfect this is for thin-walled parts. We've just turned a 3D problem into a much faster 2D one. Want to get even more efficient? Let's take it all the way down to 1D with wires and strings. So what's the difference? Beams can bend, like a wire. Trusses only push or pull, like a string. I mean, a whole complex I-beam gets boiled down to just one single, super powerful line element. Okay, so you've got all these tools. How do you pick the right one? It's actually pretty simple. It all comes down to a rule of thumb, the ratio of your part's thickness to its length. And here it is, all laid out for you, your ultimate cheat sheet comparing geometry, loads, and cost. All right, let's wrap it all up with a few key best practices you should always keep in mind. Remember, always start with the simplest element that's valid. Use that HL ratio as your main guide. So, is your model a picture of reality? Or is it just the simplest tool that gets you the truth?